Hello and welcome to another of our career interview series at Eureka Lab. I am your host, Bethany Brookshire. I am the writer of Eureka Lab, and today I have a terrible cold. I don't know if you can hear it, but I'm still incredibly excited to be here because today I am delighted to be interviewing Myron Blosser. Mr. Blosser is a biology teacher at Eastern Mennonite High School in Harrisonburg, Virginia. He is the winner of the 2013 Virginia Outstanding Biology Teacher Award. And when I was in high school, he was my AP biology teacher and one of the people that started me on the road to science and where I am today. So I'm absolutely thrilled to have him here. Hi, Mr. Blosser.
Hello, Bethany. It's great to see you again. It can't be that long ago that you were in my classroom.
It was a good decade or so. But anyway, I would like to hear about your job at Eastern Mennonite. What exactly do you do as a biology teacher and as head of the science department there?
That's a good question. School starts here at 8 o'clock, and I am always here by 6:30. And so being the kind of biology teacher that I think I need to be means getting here early. Science might be a little different than English or math or social studies instruction, because we have labs to set up, we have labs to take down, glassware to wash. We have so much equipment to take care of that it takes a lot of extra work to take care of that equipment. So my job not only involves teaching, and I love to teach. Currently I'm teaching two sections of 10th grade biology. I'm teaching a section of advanced placement biology, and I also teach a biotechnology class that focuses just on biotechnology principles and applications. So with those different classes, that means different labs, that means different equipment, that means a lot of supplies and materials. So I spend most of my day actually not teaching. And so that's kind of what it means to be a science teacher. Is it means you spend a lot of time working with budgets, buying materials, supplies, and even washing glassware.
I will admit I actually never thought about who washed my glassware in high school labs. Thank you for washing my glassware.
You are welcome.
So on a daily basis, how do you prepare for class? What kind of preparations do you do? When do you do a lot of your preparation, your grading, things like that?
Well, once again, getting to school an hour and a half before the students allows me to do a lot of the preparation. So that's when I take care of the physical preparation for the day. Also after school is when I take care of the physical preparation of the day. But all of the grading, all of making out of tests, quizzes, any kind of review sheets, all of that takes place in the evening. And so when I go home in the evening, I spend my evenings usually in front of the computer or grading papers. So in a sense, I take my work home with me almost every day. And so I try to think, okay, what parts of my job can I do at school? What parts of my job can I take home? And those parts I can take home, I usually do take home. In addition, I am working at kind of flipping my AP class, which means that I have videos that I create and also videos that I find online for my students to watch, and I post those. So all of that I do at home because I don't need to be at school to do any of that. So at school is when I do the prep for labs and in the classroom kind of preps.
Wow. So it sounds like there's a lot of work involved in being a science teacher. What made you want to become a science teacher?
That's an interesting question. I grew up loving the outdoors. I grew up loving what we now call the natural world. I grew up on a farm, and I would wander around the farm, hundreds of acres, with my BB gun. But I would wander around just enjoying what I could see. And so I had this fascination for the natural world, for life, for how things work, how things grow. And it was actually my high school biology teacher that first kind of put the idea in my head that I could actually have a profession talking about and studying that which I fell in love with as a little boy. So that probably was the first idea that I had when I was in high school biology, that, man, wouldn't that be fun to talk about this stuff all day long? And then when I went to college, I majored in biology. So I have my bachelor degree is in biology, and I took a class as a freshman called Exploring Teaching, where they had us go out to a local school, and I went to Harrisonburg High School, and we simply kind of shadowed a biology. I shadowed a biology teacher there, and I realized that that was something that I think I could do. And so it was that freshman biology experience, it was my high school biology teacher, and it was all those years of growing up on the farm that I think made me decide, you know what, this is the profession for me.
That's great. And it's clear that you really love your job. You love what you do. What do you love most about, being in the classroom and about teaching high school students science?
Well, one of the things I think I love the most is the idea that I can help others learn about that which I am passionate about. And what I mean by learn about it is I can actually help them achieve their goals. And so when I see my students, I try to think of what goals might they have that I as a teacher can help them achieve. It might be getting into the college of their choice, but for me the ultimate goal, of course, is to learn about the natural world, and that includes learning about yourself. And so to me that brings a lot of excitement to work at that. And to be honest with you, I think one of the things that keeps the excitement in me is I'm a risk taker. I like to push the envelope, as they say. And so for me, I like that idea of trying to be in a profession where I'm encouraged to take risk. And those risks are risks that I think enable my students to have a better experience in school. And so for me, every day is trying to find out how can I take better risk, how can I teach in a way that actually encourages others maybe to learn more. And what I've come to is the idea that my students need to experience their learning. I think it's Mark Twain that has that quote that says, "A man who carries a cat by the tail learns something he can learn in no other way."
I bet.
So I take that to mean that if I can get my students to experience science, they'll learn things that normally they would not be able to learn. And so that idea of creating excitement in science is something that it keeps my passion high, and it involves risk taking, and it allows me to have my students kind of fuse collaboration with others, with scientists, with trying to be relevant, and also having my students be dynamically involved in what they do. And so I kind of bring those pieces together, and so that's what kind of stirs my passion.
So you have a couple of ways in which you get students really involved in science, and one of them is you run discovery trips. Mm-hmm. When I was in high school, it was called Coast to Coast, I remember, and I went on one, and it was a formative experience for me. What gave you the idea to do these discovery trips, and what do you feel their purpose is?
That's a good question. I think one of the reasons why I have tried to take these trips is it's like the ultimate risk. To take a group of high school students for a month, across the United States, meeting with people, and learning science in the environment that you should learn it in. So for me, it's like the ultimate risk-taking. So there's a little bit of adrenaline behind that idea. And then I was surrounded by other teaching professionals at Harrisonburg, you may remember, that were very encouraging and very supportive. And so I think those early years of support and encouragement allowed me to take risk that I'm still taking today. One of the things that I've noticed about these trips is, and they are about 8,500 miles we travel in about a month. We travel in a full-size motor coach. We take some of the seats out. Now we have a generator on board. We have wireless hubs, so we have constant internet access. The students camp, and so every night we pull up to a campsite. We set up our tents. We cook our own food. But the nuggets are when we meet with professionals. And so we meet with all kinds of people that help us understand a variety of case studies. The last couple trips, we start by meeting with Wendell Berry. And Wendell Berry is an author, a writer. And so we sit around the fire with Wendell Berry and have him talk to us about his passions for the natural world. And then we start doing case studies, whether it's agriculture, whether it's water, energy. This past summer, we did technology. And we stopped at Google headquarters in California. And the students were able to see the robotics car that drives around without anybody manning it. And we talked about what role does technology play in our lives. The last night of our trip, we spent on an Amish farm.
Wow.
So we got to see this dissonance. And I think probably the dissonance piece is the piece that I am the most excited about. If you think about dissonance, dissonance is when things come together and butt heads. They clash. And so that's the model that I try to use as we cross the United States, studying these variety of issues. You may remember studying the brucellosis bison issue in Yellowstone.
Yes, I do.
Yes, and that was a big dissonance piece where we talked to a rancher who shoots the bison when they come out of the park. We talked to an environmental group that wants to protect the bison, and then we talked to the park biologist who's caught in between. So we like to use that model if we can to allow students to realize that within the United States there's a lot of exciting things going on that we need to learn about. I've noticed that a lot of our students today cross the ocean and go to all these different countries but never go past the Mississippi. So part of my passion is for students to learn their own country, and this discovery trip allows them to do that.
So when you said about setting up, I mean, now you've been doing these discovery trips for a pretty significant amount of time. When you first set them up, how did you find the people and the places to stop at? How did you go about setting it up? How did you get the funding? How did you handle it logistically?
Mm-hmm. Well, actually, the first trip was back before we did a lot with email. And so we kind of eased into these trips without having the technology that we have today. In fact, on the first trip, we took a satellite phone just in case we needed to make a phone call. And I remember that we were charged over $7 a minute anytime we wanted to make a call on that phone.
Wow.
Oh my goodness. Now, it's a whole different world. But the way that I started this was simply by listening to the news, watching the newspaper, trying to find out what are the hot issues in the United States that we need to learn about. And I remember reading in USA Today about this student who graduated from Humboldt University while tree sitting in one of the giant trees out in California. He was protesting it being cut down. So that gave me an idea. Let's meet this man. Let's talk to him about his passions. That, of course, led to the dissonance where I said, so who would want to cut it down? Well, it was the Rough and Ready Lumber Company. So then we contacted them, and that's how we set up that dissonance piece. So it's learning about the issues that face us and then trying to trace down those persons that we think can best articulate that for our students.
That's an amazing amount of dedication. The students, and I know because I did it, get a truly amazing amount of inspiration and learning out of these trips. What do you hope that they really gain? You emphasize dissonance a lot. Do you hope that they gain critical thinking or, deeper knowledge of issues?
Yeah, that's a great question, because the essence of this trip is for us to understand issues from multiple perspectives, to be able to hold those multiple perspectives in our hands and play with them a little bit. In fact, I remember one student, it may have been on your trip, that told me when we got back, he said, I thought when I went on these trips I was going to find the side of each of the issues we studied that I would champion. Now that I'm back, I realize that my mission needs to be to bring the parties together and have them discuss the issues. So that's really what I want, is for students to be able to see that there are good points of view on both sides of issues, and for them to be able to understand the value of listening to multiple perspectives and not simply jump in one camp immediately and ignore perspectives from another position. So that's kind of the non-scientific values of this, along with learning a tremendous amount of science.
On the other hand, I mean, I would say that learning to look at several sides of an issue is actually a very important thing when doing science. You need to be able to give up your pet hypothesis and say, yeah, I guess, this might be more complicated than I thought, or it might be wrong. You need to be able to consider other options. It could be pretty useful for science as well.
That's true, and I do think it makes them better scientists. In fact, one of my joys is to take students on these trips that I will teach the next year. They are different students, and so it's really exciting for me to teach students that have been with me for a month, and on these kinds of explorations. We understand each other much better, and we both kind of see things differently than we did before these trips. So you're exactly right.
So that's not the only awesome thing you do to help get students interested in science. You also run a Biotechnology Symposium every year. What is it, and what does it do?
Once a year, it's usually in March, we set aside a day, and we invite the local schools. Usually it's anywhere from 10 to 20 different schools that participate. They send a group of usually upper-level students. A lot of them are students currently enrolled in advanced placement biology. We come together for a day of concentrated biotechnology discussion. We start with a keynote speaker. We've had a scientist from Monsanto, Francis Collins from NIH has been here.
Wow.
Augusto Adone, if you remember that name from Lorenzo's Oil, he's the father of Lorenzo. He came and spoke. We've had a variety of speakers that come, and they're pretty significant speakers. And then after the keynote, we oftentimes have a time for students to ask questions. And then we break the students up into two groups. One group goes off and does lab work. Now we have about 6 or 7 labs at one time. The other half of the students will go to additional seminars and learning activities. And then we switch the students. So about half the day is spent with a keynote and a major idea. The other half of the day is usually spent working with techniques, learning more about biotechnology, manipulating DNA, running gels, doing a lot of the more biotech-y kinds of things. This year will be the 21st. Wow. And usually we have about 400 students that come. So it's been very successful, and it's very exciting, and it's just a fun day.
That's really neat. So, you have all these great ideas, and, it's clear that you really want to inspire these students, and you get a lot of them involved in research. How do you go about making the connections to help students get into laboratories? Do some of them work in laboratories at universities? How do you make those connections?
Well, that's an interesting question. In fact, I had a teacher stop me in the hall a week ago, and that teacher said, I want to do what you do. So can you give me some ideas of things I can have my students do? And I looked at this teacher and I said, have you ever heard that you need to bend your knees before you jump? And he kind of got this questioning look on his face. And I said, you need to experience things before you can learn how to have your students experience things. And so one of the values I think that teachers need to think about is themselves getting out, learning to know people in their discipline. So for me, that would be scientists, so that I have contacts. I spent a month up at Cold Spring Harbor Labs working on molecular genetics and met Jim Watson and talked with him on almost a daily basis. So that's just one example of a place that I've become familiar with. I know scientists now all across the United States. I make it a regular habit to wander into the science buildings of the 3 colleges that we have here in Harrisonburg, simply because I want to learn to know them. Once I learn to know them, I've got a contact. And so as soon as I have students that have a question or that would like to work in a lab, I've got 10 or 12 different ideas immediately because I know people. And so I'm constantly learning to know new people, learning to know what research they do, and then working to get students involved in those different pieces of research. So it's a constant effort on my part to push myself to learn to know new people, new techniques, new ideas, so that I have places for my students to plug into.
That's really great. So, have a lot of your students gone into, STEM, science, technology, engineering, and math? Do you think you have a higher number that have gone on to that than average, or do you produce a lot of students that have a really good scientific awareness in general?
That's an interesting question. I don't have any hard data on that one. Interestingly enough, my head of school asked me a similar question very recently about, do you have any idea how many of your students are medical doctors? How many of your students are in the medical profession or are doing bench research or somehow doing science research? And I really don't. Although I do know that I have a lot. There's a lot of students that I teach that go off and do something in a scientific field, which is very exciting to me because they keep in touch and I get to find out. And now the cool thing is, just like you, now they are becoming my peers. And so now we are actually working together, where you used to be my student, now you're my peer worker in education. And that's very exciting for me.
Well, I would just like to say you haven't aged a day. You look totally the same.
Oh, well, thank you. Thank you.
Do you have any advice for, say, students who realize that they love biology and that they want to be a biology teacher? And do you have any advice for, biology teachers who might have, big ideas for ways to get their students interested but aren't quite sure how to implement them?
Mm-hmm. There's a quote, I think the quote comes from Eleanor Roosevelt. I'm not really sure where the quote really originated. And the quote says something like, small minds discuss people, average minds discuss events, but great minds discuss ideas. And so I think part of my advice would be for teachers and students alike to try to start having conversations about scientific ideas. Get off of the people thing, and get off of the major events that have occurred in science and start having discussions centering around scientific ideas. And that breeds a lot of questions. And if you've got questions, then you have a directive. And so once again, I'd probably advise teachers to bend their knees a bit. Try to do things that might involve a little bit of risk. There's an old saying that says that people will gather around a fire, like a house fire or a barn fire, to watch it burn. And so I think excitement breeds excitement. And so when your classroom is on fire, and usually it's on fire because of ideas, then people will gather around you. One of the ways that I tell teachers that they know if they're successful is they have groupies. Groupies are students that just want to be in your room, They just want to hang around because they never know when the next idea is going to be birthed, and they want to be present. And so that's the kind of atmosphere I think you want to work at, is to build anticipation for when's that next idea going to come. And usually they come when I'm talking with students. And so students want to be in those conversations because they could be the birth of the next big idea for that. So for students alike, I would encourage them to start thinking about scientific ideas. Learn about things that are current and today, and ask questions, because those questions, once again, will give birth to ideas for research. And by the way, don't be afraid to ask. I'm impressed daily how you can send an email or call someone on the phone that is a significant scientist, and they will take the time to talk to you and to respond to your emails. I tell my students the most they can do is say no. So I would encourage people to not be afraid. Walt Disney had that quote that I like. I actually have it hanging on the wall of my office. And it says, the way to get started is to quit talking and start doing.
That's fantastic. This has been just an amazing interview. I do have one final question, though. Mm-hmm. What is the weirdest thing that you have ever done in the name of science?
Probably the weirdest things involve putting things in my mouth. Probably licking the slime off of a banana slug in Redwood National Park to show students that the slime causes your tongue to become numb. It was pretty weird. We had a bus licking contest at one point where we would try to see who could jump the highest, and the way you would mark your height is by putting a wet lick mark on the window of the bus. One time I had a contest with a student to see who could keep a pine needle in our mouth the longest. And so I kept a pine needle kind of perched up inside of my cheek. I think it was for 3 or 4 days. But then one morning I woke up and it was gone. So I don't know if I swallowed it or what happened, but the student won that bet. So somehow they always center around eating strange things or licking strange things.
Well, I will say that actually on that trip I also licked a banana slug for science. And there's still a photo of me with my numb tongue having licked a banana slug.
Yes. Oh, that's a great moment. It's a great moment. So,
well,
jumping
thank you
into
so much.
Also, I was going to also say, in jumping into a high country lake in Glacier to show students to demonstrate that was pretty significant. The water temperature I think was 34 degrees. So that was one of those moments I won't soon forget. So.
Or possibly repeat. Well, thank you so much for coming on and doing this interview. You have been an inspiration to me in many, many ways, and I'm sure that you have been an inspiration to many other students as well. So thank you so much. Congratulations on your Outstanding Teacher Award, and thanks so much for telling us all about being a science teacher.
Well, thank you for this opportunity, Bethany. It's great to see you again, and I'm impressed with what you are doing. So thank you for this opportunity.